Remember that we're trying to answer this question of how do we find the measures of sides and angles in a right triangle. So any questions about what we're doing today before we get started? Okay, so let's take a quick look at my wonderful drawing skills here. They're horrible, but please bear with me. You'll get the picture. Okay, so I know, it's bad, but you get the point, right?
I don't get the point.
Okay, so we're outside all the time, and sometimes we see a really tall tree, and we're like, I wonder how tall that tree is. You ever do that?
No.
Occasionally. Only if it's really tall, right? Okay, so let's say we have a really tall tree, and we know how far we are away from it. And yes, we're lying down, it's summertime, it's gorgeous out, and we're just staring up at the sky, and we're like, wow, that tree's really tall. It has to be that way to be a triangle. Well, it doesn't have to be that way, but those are more complicated problems, so we're going to stick with a simple problem. This is easy to measure, right? We can get one of those little track wheels and measure how far from us to the tree. But I don't know about you, but unless you're willing to climb up to the top of that tree and drop a string down and then measure the string later, it's kind of dangerous to go up a tall tree, right? Unless you like get one of those trucks that can get to the top of tall things. Let's say we don't have that at our disposal, but we still want to know the height of the tree. That's what we're trying to get to today, is how can we do that? And I'll give you a little bit of a hint that if we have this angle measure here, and notice we have right triangle, right? And we know this distance here, that's enough to give us the height of the tree. So that's where we're headed. So I want to give you one more example because I'm hoping, I had this idea last night, and so I haven't been able to do the research, but would you mind pulling the blinds up? So I don't know if you've noticed, but outside, and if you can't see, you could get up and look if you want to, there's a cell phone tower across the street. And I have often wondered, how tall is that? Like it's really tall. And I'm definitely not going to be able to get up there to measure it, right? And I don't think we have measuring sticks that long. But if I could arrange it, should we try and figure out how tall it is? Yeah. Similar method? Yeah? That would be kind of cool, I think. And I don't know, because I'd probably have to talk to the township, and I don't know that they'd let us over there, but could do a little field trip across the street. That'd be kind of cool. All right, anyway, I have no idea. I thought of it last night, and I thought, well, maybe if we could do that. So you can put the blinds back down. Okay, so it looks like most of you have that initial line drawn to make your initial triangle of ABC. A couple of things that I wanted to mention. Make sure that you're keeping track of all of your triangles have to be on the grid, right? And then all of your line segments, the long line segments that you're drawing have to hit the axes, okay? And I want you to think about why that's the case and talk about it in your groups if you're not sure. So just a quick show of hands, how many of you are on the first page? I think I've been around to everyone. How many of you have moved on to the second page? Okay, and then please remember that once all of you in your group have gotten to the point where you've calculated those ratios in that table, if you are sure that your ratios are correct, you can take your marker and go to the correct poster and write down your there's 9 numbers total, but 3 in each column. And you don't have to say who you are when you put your numbers up there, and make sure that the numbers, again, you write them big enough with your marker that somebody across the room could see the numbers. Questions before I have you get started? Okay, you can get started. I think we were talking about this yesterday. Did you figure out if your lines are parallel? Does that make sense? Because when I look at here, parallel, I should just be able to move it out. Does that make sense? So it looks to me like they're tilted a little bit. Do you guys see that on hers? So some of you might have parallel lines. And maybe so you compare and say, okay, well, what makes Maddie's different? How does she fix hers? Does that make sense? Now, you figured out your slope, right? And your slope was easy to calculate. Not everyone's slope will be as easy. You got group number 1, right? That will be something that, as if you walk around, if people have moved on to measuring to make sure we have parallel lines. Won't work very well otherwise.
So,
So for to equals, does that just mean?
So I was thinking you'd put the two numbers there. So whatever the measurements are of these two, because you've written down which ones are which. So put those two numbers in a fraction and then in a decimal. That way you can see it both ways, the ratio both ways. How did you get the one up there? Okay.
I think I did it wrong because it says the slope is
Uh-huh. It doesn't seem like it's that high. So what maybe did you need to change?
Is this supposed to be X up top and Y on the bottom?
Y on the top. Mm-hmm.
Oh, I put the 10. That's it. It's supposed to be 10. After up top.
Think you're on the right track now?
I got it.
Okay.
I think you figured it out.
And so how'd you figure out where to put, so you started up one here. How'd you figure out where it was going to intersect the x-axis there? Oh, gotcha, okay. So Carissa, you figured out where to put your lines. What'd you do to do that? A slope of -1?
Yeah.
Okay.
Like when,
The first triangle is the only one that has a coordinate.
because these two are
You were
like,
able to do that?
like, yeah, how it's like 10
Okay.
here and 10 here, I knew that they would be exactly corresponding numbers
Okay.
each time.
So maybe you can work with these guys and figure out together, since you're already done with that part, how can you take their original line and move it out or back in? Something for you guys to think about is you know your numbers, but you also know transformations. And we're just making similar figures here, right? We're trying to make parallel sides, so how might we do that? You don't have to do it that way, but just some ideas to get you started. I'll come back around and visit with you and see how it goes. Well, is it? What do you think? So how would you know? And so are all, you said, so parallel line with the same slope, so do all three of your lines have the same slope? Okay. How are you doing? Can I take a quick look at your lines with you? All of you. So did you all look at each other's, like what your lines look like? And what did you decide? How did you create your parallel lines? Okay. So for a slope of a -1, how'd you decide where to draw that next line? Did you eyeball it? I mean, it's a method, right? And then how do you know that you're right? Calculating the slope to make sure. And then so what'd you do over here? Because you know your slope. So your original slope is here. A, B, C. Oh, this is your original one here, right? And so what's your slope on that one?
He really didn't tell me. He just said the other guy was
So what's your slope
Also, it
then?
wasn't like our student.
Huh? No.
Is that an equivalent slope? You see what I'm saying?
Yeah.
So you want to, before you start measuring, make sure you have exactly parallel lines. So So confirm that your slope is going to be the same. So you said down 10 over 3. So how would you represent that as a fraction then, as your slope, as one number? Right. And then you're going from left to right, uphill or downhill? I mean, that one will be easy to see, but so it's going to be negative 10 over 3? Does that make sense? And then do you remember how to calculate slope if you need to? Okay. The change in the y's over the change in the x's, or y2 minus y1? Right. And then if you guys want to listen, let's see what Mason did too.
Just did down 3 and over 10 because that was the original slope. And then I just continued the line.
I think we talked about this yesterday. Can you tell them like where your lines were and like how you moved it?
I just did the same line, one square up, down 3 over 10, and then continued it so that it went over x.
So you really did a translation, right?
Yeah.
Does that make sense? So he just translated the original line segment up and then extended it out? Because a translation will give you parallel lines too, right? So it's something else to think about to try and get exactly where they go. And then Mason, did your lines end up intersecting that x-axis right on an integer?
No.
So that's something to think about too. He went up 1. Oh, sorry, it would be up 1 here. But then when he extended that line down, it didn't necessarily hit at an integer value, right? It could be in between. Does that make sense? Okay, excellent. So make sure that you have parallel lines for sure before you start measuring. Yes, sir. Mm-hmm.
How do we find
Like,
hypotenuse's length?
where is it?
Oh, for all of them, you're measuring in centimeters. Notice that it says centimeters up here. So don't measure in units, measure in centimeters. And to the nearest tenth of a centimeter, too. So try and be very precise. Good? Okay. How's it going? So it looks like all of you are on ratios. Do you mind me looking at your parallel lines with you for a minute? I'm sorry to interrupt. So how do we know that we all have parallel lines? Did we verify our slopes are all the same? You should, right? Because all of the work you're doing on that back page won't really make sense unless your lines are parallel. Because we do need similar triangles, meaning lines are parallel to their original, right? So you can calculate your new slope and make sure that it's the same. I mean, visually to me, it's fine, but
Dilated.
you did what?
I dilated the line.
Oh, gotcha. So how'd you dilate it? What'd you do?
I took 1.5, like I chose
The scale
that
factor?
scale factor
Uh-huh.
and then multiplied the original like 5 from the
Times the scale factor to figure out where the new point went.
yeah.
Cool. Comes in handy what we learned last term, right?
Yeah.
I like the fact that we're using what we spent so much time on last term. All right, awesome. So as long as you guys know you have the right slopes, and you, if you want, double check each other's, because again, you don't want to have to come back and remeasure.
If you do, because I just said if you do rise over run, and so like if you go up 5 over 1.5 to 9, then you go up 10 over 3, go up 15 over, so the pattern is this multiplies by, or you go
By 2, by 3,
and then
yeah.
1.5 plus 1.5.
So you feel like you're okay? Those are equivalent slopes? All right, excellent. Yes, ma'am.
So if this is 103, like, I'm confused because it's not. Yeah, it's 5. It's not meeting like the point
So,
everywhere else.
so the only points we know for sure are 10, 0 and 0, 3. All the other points visually, we don't know for sure if it's hitting in the right spot or not. Does that make sense? Like, we don't know that 7 comma 1 really is a point on our line. It could be 6.99 comma 0.99.
Okay.
So use those 2 points and actually calculate your slope. And then also, I've seen some other groups consider using like either translations or dilations to figure out like where to put their new line. So that's another thing that you could think about doing. Like if you just were going to take line CB and move it, translate it,
Okay.
or if you were going to take and dilate points C and B, like if you were going to dilate this, let's say by a scale factor of 2, then where would that point end up if you need a scale factor of 2?
Okay.
Does that make sense?
Yeah.
Now that might be too far, but maybe 1.5 would work, or does that make sense?
Yeah, it makes more sense now.
And be patient with yourself. If you're behind on this part, it'll be better because you'll still have measurements, and you know what I mean?
Okay, thank you.
And Austin, if you feel like you want to try and help her out a little bit, that's good too. Yes, sir. Sorry, Michaela, I'll be there in a second.
I'm not thinking this is right here.
So can we all look at our parallel lines for a second? How many of you feel like you for sure have parallel lines? I don't think Kyle's in that group yet. For sure, Tyler, or no?
Yeah, for sure. I'm gonna be confident.
Okay. So did you guys do the same?
We didn't do the same.
Okay.
He didn't want
So if the lines are parallel, what should be true about them?
They should be
What do we put here?
that same slope.
Same slope, okay. So that means that to verify, we need to actually calculate the slope of each of our lines for it to be the same. So Tyler, just visually, I'm looking at the distance between, the distance between your 2 lines here versus there. It doesn't look the same.
So they're not that long.
Visually, does it look visually like they are?
Not really.
I mean, if we're being accurate, then visually it should look parallel as well. And then you can double check by using whatever point you know for sure. A couple of other groups have either translated their line segment or they've dilated the points that they had. Does that make sense? Because you'll want to check as well if the slope of this line segment is going to be the slope of that line segment there. And then I'll come back around because I see you guys are kind of working on it. So you have the one that was easy to do because it's -1, right? So when your y goes up by 1, your x goes up by 1. These guys are in a different scenario, so see if you can help them brainstorm. Does that make sense?
After I do this, go to council.
Yeah. Okay. How's it going?
Okay.
Can we look at everyone's parallel lines first? We'll get there too.
Yeah, and then it didn't end up looking right.
So what did we say, those of us that have done number 2, what did we say about how we know they're parallel?
The slope is like the same.
Slope, it has to be the same, right? And then so yours is a slope of -1. You get the easy one, right?
Yeah.
When your y goes up by 1, your x goes up by 1. Austin, yours was not quite as easy. What'd you do? Your slope is 3/1. How did you figure that out?
And then rise over run.
So your original points are B and C, right? Is it really over 1 down 3 every time?
I know what I'm doing. Yeah.
Are you sure? Because it's 10. The total is up 10 and over 3. Wouldn't it have to be 9 and 3 to be?
Oh, I guess Austin's will be wrong slope.
Shame on him. That's okay. So does that make sense? So your slope really isn't -3 over 1.
Oh,
Does that make sense?
Yeah.
Down 10 over 3. So what I've seen a couple of other groups do, so just as some ideas for you, because I want you to try and talk about it and see if you can try and figure it out together, is they've used either translations or dilations to figure out where they would put the next line segment, and then they just extend it if it needs to be longer or shorten it if it needs to be shorter. So see if you can think about that for just a minute. I want to help you through it, but I want to see if you have some ideas on your own. So I'll go to another group and then I'll come back in a couple minutes. Does that sound good? Okay. So see if you can do it with them.
I don't even know what I did, but
Well,
that's okay.
well, yours is a little simpler situation, right? Because you were able to go up 2 over 2 because your slope is -1. So every time you do go over 1, you're going to go.
Yeah, I did like, okay, so this was like my original triangle, and then I did like up 1 because I did like the reverse of it.
Okay,
And then I did,
right?
like,
But if you thought about yours as, for example, either a translation
yeah, it's
or
just
a
like line
dilation,
over 1.
right?
Yeah.
So from here to there, you can think about scale factors. That might be a way to think about your dilations. Okay, I'll come back. Okay, ladies, can we look at your parallel lines for a minute? Just because if you do the measurements but your lines aren't parallel. Okay, so how did we figure out that our lines are parallel? Or do we know for sure that they are parallel? Same slope or same scale factor? Same slope? Okay. And we verified, so show me with this one here, or tell me how you would verify that your slope is the same as your original line.
Well, I basically just picked. Originally, I had them like all the way out here, but then I kind of realized that they needed.
Oh yeah, they need to cross the y-axis. Yep.
So I had to make them smaller, but basically I just picked whichever point was the closest, and then I went down by the same slope as the original picture.
So talk me through. So what's your original slope? Like, what's the slope of this line segment?
Or -3.
So it should be -3, 1, -3, 1, -3, 1.
Oh, so is that off a little bit?
Uh-huh. Can you see that?
Yeah.
Because this is 10, and this is 3, so it doesn't divide into an integer. It's not an integer.
Yeah. Okay.
So what is your slope actually? Just go straight from here to there.
-10.
So yeah, I don't want you guys to. You've already done a bunch of measuring, haven't you?
Yeah, I have. I did.
Okay, you're gonna have to fix that first, and then. So did you do it something similar?
Yeah, I did negative.
So you did -3 over 10. And how do you know for sure that this line is -3 over 10?
I guess I don't know.
So just to give you a couple of ideas, and I'll come back and visit. I've had a couple of students do a translation. So they took the physical line segment and translated it, right? And so they figured out where it would go. I've had other people do dilations, like try and figure out a scale factor that might work, and then dilated those 2 points.
But
So
how would you? Well, mine is these lines still.
So you're up 1 from here, and then up 1 to here. So could that one be okay?
No,
No?
I don't know.
So from here to here, because this would be just translated up 1 unit, right? Your line segment translated up. So do you still have a slope of -3 over 10?
Yeah.
Okay, so that line's okay. And so this one looks like it might be translated down just a little bit from there.
So I think this middle one's just wrong.
Might be just a little off. But I don't know, because I look at the distance here and the distance there, and then it might be okay. But maybe just remeasure, because you have at least one person that needs to fix things. And I would try and help each other get on that page before you do all the, the rest of it. Does that make sense? And yours was a slope of what?
10 over 10.
Right, so when you went up another 2 units, you could go over another 2 units because it's 2 over 2, which is the same change in slope or change in position. Does that make sense?
Wait, so you want me to go?
Your slopes are fine, right? Because you're still going down 1 over 1, down 1 over 1, down 1 over 1. You're lucky that you're.
So do I have to remeasure or no?
I don't think so. Do you think so?
I don't think. I mean, I did it when I did it. I wanted to make sure it was all on the same.
Right. So you made sure that it crossed.
Yeah.
Because you know when it's a slope of -1, it's going to cross those diagonal like intersections. Okay. Did you have a question?
Do you want me to write them for each one, like each line? Or
I only need that number.
Oh, okay.
So just continue down here.
Okay.
Yep.
I wasn't sure.
No, that's okay. I understand.
Sure. All right.
Yep, you're good. And then so you'll want to do the same thing with yours, is to verify.
Mine's 5 over 8.
What?
Is that
Just
counted?
I'm translating. Okay. Do you see what?
Yeah, I just don't know how I'm supposed to figure it out if I was to do it through definition because then, that would go off of the grid.
So maybe Maddie, can you help her with what method you used, and maybe she can use the same method? And then I'll come back and see, make sure. I would rather we spend the time to make sure we understand this part, because it'll really help us later to understand the concepts. How are we doing?
Great, actually.
Yeah? Have we looked at your parallel lines? We did, right? Okay. And we got through that. We think we have all parallel lines now. Cool. Okay. Did we get to parallel lines, we think?
I figured it out. Look at that.
Did we get to parallel lines?
Yeah.
Or we're getting there? Yay. Maddie, did we get to parallel lines? Yay. Parallel lines? Or maybe not yet?
I'm helping them with their parallel lines.
Okay. A method that has worked for other people is they've taken their original line segment and gone up 1 unit on the y-axis, and then they've taken their end point on the x-axis and gone up 1 point, up 1 unit there, drawn the line, and then extended it down, just to help you out. Because it's close, but it's not quite, right? Because if you look at this line segment, if we translated it up 1 unit, then this point should be there. So it's not going to end up, like your line won't necessarily cross right at an integer on the axis. Okay. Did we get parallel lines, or we're still working on it?
Oh, I got my parallel lines.
Okay, so let me. So when you went up 3, you could take this point and also translate it up 3, right? You've just translated up 3, and then continue that, extend that line segment down to the x-axis, wherever the ruler takes you.
Okay.
Does that make sense? So we're just using a translation up 3, and then we just got to make it a little longer.
Okay.
Good? And then let me see.
I guess
So you went up 1. Up 1. To make it exact, it should go right through that intersection right there. Yep. And then up 1 again, so it should go through that intersection. So we're just translating the line segment.
Yeah.
And then use your ruler to make it cross the
Okay.
x-axis.
Got it.
Do I have to do this? Like, I wrote number 4 on one of these things.
Oh yeah, number 4 is over there,
And
over on the window.
so do I just write that number?
Yeah, just 0.85, 0.841, 0.853 in the first column, and then your 3 numbers in the second column. Oh, Sydney, you don't have to write out all that.
I don't have to write out all of it?
You can just write 1. It's okay. It's all right. It's not the worst thing in the world if you... Because we'll still be able to see the numbers.
Megan.
But I'm thinking we have how many more groups? Oh, we'll figure it out.
Just write first one.
I'm sure. I'm sure.
Vertical.
Don't worry about it.
Okay.
I could.
You don't need to write out the whole box, just the numbers, yeah. So yeah, you don't have to continue that. I would just write your 3 numbers.
Just the decimal.
Yeah, just the decimal. It's important to be able to, for you to be able to see on your paper the fractions too, but if you notice there's a pattern in the decimals, or kind of-ish. So how far are we?
5. Let's talk about the
Okay, so still working on the table. Okay.
Basically, yeah.
The base leg is the same as the hypotenuse.
He's making
Oh
progress.
wait, never mind. No, it's not. It just happened to be in this.
He's making progress.
Let's see where you are.
Why are you messing with my ruler?
So you could think about this one on your own and see if you see any relationships there. You could try this one, but then of course when they get to that point you'll want to come back and look at it with them. Just wanted to see what you... Okay.
Can we just leave it as a fraction?
You're going to need the decimal too. Remember when we did that practice yesterday and we looked at the scale factors 3/2 and 1.5, and in some cases it was helpful to have 3/2. In some cases it was helpful to have 1.5. So if we have both, we can choose which one's more helpful. So when you have all your numbers, you can go put them on your poster also.
Like these
Yep,
ones?
yep. So you're just putting your decimal version
Oh.
up on your poster. No, we just want everyone's values so we can see them. So what are we working on now? Oh, we're doing the whole investigation. Oh, you all went through all of it? Let's look. So you said for yours,
I tried to explain in words how to do this, but I said
Okay.
it just kind of.
so what did you decide your length of AH is?
Well, it
Did
just
you
says
get there?
Describe, it doesn't say solve.
Oh, gotcha.
We just like.
Okay, maybe try and solve and
But
see
even
if you would
without
get.
the other side lengths, how would we figure out? What are these?
Well, so each of you has different triangles, right? So for your triangle, so HJ is what side of the right triangle? Right. So if your hypotenuse is going to be 525 centimeters, you have some ratios here, right? And we know that, like, what did you notice about this ratio there?
It goes down from the first one.
This one here. I think you want to.
Or no.
So I'm noticing this one. Look at that one. Those are all kind of close to each other, right? So how about those right there?
That one's a little off.
Well, I was going to say 2.5 divided by 9. Is that?
I might have wrote it wrong.
And did you talk about number 6 together? Because you guys, number 6, yeah.
We said that.
Oh yeah, I just
We
wrote
said
that.
how we like compared the graphs and how like Nadia's and mine we had like the ours were more
Bigger angles.
yeah when they had the smaller angles. And
So
then
some
we
people
said
had small angles, some people had big angles. Okay.
And then we said how the ratios like they got bigger and smaller. Like Nadia's and I got bigger as we went on, and theirs got smaller as they went on. So they started out.
Did you notice any patterns going down looking at your ratios?
didn't do that, but I mean, mine increased.
Okay. Because being able to see if there's any patterns going down, because your triangles are similar, right? So if your triangles are similar, you should see similar things, right? Is that making sense?
Yeah.
Because we know we have similar triangles, so when we compare, like I want you to think about what we did yesterday, we knew that the scale factor was always going to be 1.5. So what are we seeing here that does that make sense? Because this is how do we compare the original to the image. This is how do we compare in each of these 3 triangles 2 side lengths compared to each other. Because I'm noticing, what are you noticing about those 3 numbers?
They're similar. They're close.
Very, right? As I mean, if we're talking about like dollars and cents even, that's really close. How about these? And really close. And if you look at these numbers here, are they close to each other? Those numbers, pretty close. That one's a little bit different. So you'll want to see between all 4 of you, are you seeing the same type of pattern even though the numbers might be different? Does that make sense? And that will help you with ideas about how you might do number 7, like how you might actually get the answer instead of just set it up. Does that make sense? So they thought I meant write out all this stuff. So you could squeeze yours in up here.
What do I need? Just the numbers that I got?
Yeah, we want just the final decimal.
All right.
Sound good? Okay, how's it going?
Good.
Need to measure now? Have parallel lines? Yay! Okay, so you're measuring in centimeters.
Okay.
So you're measuring every side of every triangle. Just make sure you get the measurements in the right place. Measuring every side of every triangle because you have 3 triangles, right? You should label your points because remember you're supposed to label your other points here.
Okay. I just see that. I didn't know that I made a triangle.
Gotcha. Well, and you guys should try and answer these as well. And you should all try and talk about it as well.
Okay.
So Austin, when Michaela and Conrad have had a chance to try and do numbers 2 and 4, you guys should come back and see how your answers compare. And
So it'd be like D prime and then C prime?
actually, they give you names here. So the new points are going to be D and F. So this is D and F if you want. Doesn't really matter which one's which, but you want them to be in the same order on the other axis. So E and G. No problem. How's it going?
Good. I just gotta go.
Okay. And then once you get done with that part, you're trying to figure out, well, what do you see as relationships in this table? And in particular, focus on these ratios here.
Okay, so that's only for AB. Okay. Number 3. Only fill out these for AB.
You should do all 3. You should have 9 numbers total up there. Yeah, because you want all 4 or 3 of those numbers, all 3 of these, all 3 of these. So what did you guys notice in the table, that number 6?
One thing I noticed is that they're all pretty like close to each other.
So all 3 of your decimals for horizontal over hypotenuse? Okay, did you guys all talk about that yet? No? Okay, that's something that you'll want to talk about together because even though you have different triangles, you want to see, do you see the same patterns, different patterns? Is there any commonality in the patterns that you're seeing? Before you try number 7. Does that make sense?
Yeah.
Because the key to doing number 7 is in number 6.
Did it.
Yeah?
Did it? Yeah. We got it. 2, and then then you just take those numbers and then divide by. You take the numbers and then divide them forward.
What did we notice in number 6? Or are you still working on it?
I noticed that
the bigger numbers always go on top of the smaller numbers on the bottom ones.
Oh, in your fraction version?
Yeah.
And so what I'd like you guys to do is to talk to each other and say, did you observe the same thing? Because you all have different numbers, right? But do you see the same patterns?
Oh.
And if you're not seeing the same patterns, are there patterns that are the same? Because the key to being able to do number 7 is understanding the patterns in number 6.
Yeah.
Right. Yes, ma'am. Another column in each. Yeah, so like you could put yours like here or here. We just want all the numbers to be there. Right, so this is all the vertical over horizontal numbers. Everyone wrote down 3.
Okay.
Does that make sense? Yes, ma'am. Okay, which is just like 4 minutes early. Okay. Mr. Banks, 9:30 finish. Does that sound good? Okay. So you guys are starting to look at number 6 together then? Okay. Because what, and you can tell the rest of your group, what you're looking for is, do you notice the same patterns? If not, maybe why not? Are there commonalities? You know, are there generalizations that you can make? Well, do you see the same patterns? And if you don't, can you find patterns that maybe are a similar sort of thing? Because remember that you have 3 similar triangles, right?
Yeah.
So does Carissa. Everyone in your group has 3 similar triangles. So when we look at those side length ratios, are we finding similar things? Especially focus on the ratios. We doing number 6 now? Oh, you still need to measure, huh? Make sure you get all your measurements today so that you could do your ratios at home.
I don't know how to
so that we can start to talk about it
I
tomorrow.
don't know how you would figure out
Well,
525.
it's important for you guys to talk about number 6 together because you have 4 different scenarios.
Yeah.
You're looking for relationships you see in all the tables.
Oh,
Does that make sense? Patterns, relationships,
so
like,
should I erase this one?
no, that can be input into what you talk about.
Alright.
You said horizontal and vertical legs are the same. All equal 1, which kind of makes sense, right? If you're going to have the same number over the same number. Okay.
Just look right to you. I mean, I already did it all.
So did you translate over 1 and then you're going to translate over 1? Or did you translate up 1 or up 2? Think of it this way. If you're translating over 1 here, then this point's going to translate over 1 also. And then you would just take that line segment and extend it up until it hits the y-axis. So you're just doing a translation of the same line segment. Do that.
Yeah, but I already did it.
But they're not correct if you didn't do parallel lines. Come on, you can do it.
Let Tyler sit there?
You still have a little bit of time.
Exactly. So,
You can do it.
you come in, it wasn't even you.
If you could wrap up your conversations, please. So we still have a few minutes here in class, but I just wanted to touch base with you all. It looks like most of us have our ratios up on the posters. You want to, for each of you, make sure that you have that table in number 5 filled out. And if you can, have a discussion between all 4 of you. What patterns do you see? So the number 6 part. If you don't get any farther than that, that's okay. But you know, I mean, you can still work for another few minutes. But if you could please make sure that you talk about what kind of patterns do you see in your table, which is number 6. And I want you to specifically think about and talk about what is common between all 4 of the tables versus what are the differences. We're looking for what's the same instead of what's different. Questions about that? Okay, so if you'd like to work for another couple minutes or talk for another couple minutes about that, and then if you've already talked about number 6, you can relax for a couple of minutes. We can stop.